Oh, thank you. I forgot. Yeah, and just as a side note, as we record these, I am looking to put them up on the class website Blackboard, just so that you have access to these things. Thank you again. Hey, everybody. Oh, good group here. I know Riley may be coming in a little late. Hopefully she'll be able to join us as well. So what we'll do tonight then, the game plan is to walk through the factor analysis homework and kind of just play around with it and just see where it is and look at that. Um, and then and I'll go in that probably a good amount of detail. That might take a while to kind of walk through. And again, so the other thing with factor analysis, actually all of these techniques, but factor analysis for sure, because it's exploratory and it takes a lot of sort of going back and forth, it's iterative where you add things and delete things. One of the effects of it is that it tends to take a fairly good amount of practice and experience. And the more you do it, you pick up on things that start reoccurring. You start seeing them over and over again, just nuances in the data. But if it's your first time ever touching factor analysis, then it's going to be frustrating at first, and it'll take probably a little bit of just practice and doing it to be comfortable with it. And that may be true again with a lot of the techniques, but don't feel if you feel lost or overwhelmed or confused, that's perfectly normal, I guess, is the broader message. So it gets better the more you do it. And again, depending on what type of research you're doing, if you're primarily doing a lot of like secondary data research, and if data sets are being given to you, you may not have a lot of control over the actual items that are being asked or the scales that are being created. So a lot of this is like if you're doing project research where you're creating an instrument from scratch, or you're doing some of these scale work pieces, on your own, and you want to validate a scale. That's a very special type of research. So this technique, you should always double check your measures, make sure they're doing what you want them to do. And this is a good way to do that. So what I'll do, if you guys are okay with this, I'm going to share my screen. And again, I'm having to sort of switch screens, one or the other. So hopefully, for some reason, again, the one I normally use is kind of bugging out on me. So hopefully, can you guys see the Blackboard screen okay? I guess that should be up there. All right, so cool. So we'll just, so the game plan then for tonight is to talk about factor analysis, just kind of walk through, ask questions, things like that. And then we'll talk a little bit about, we may just talk a little bit about the discussion question and the article. Again, the article had a factor analysis in it. And then we'll probably spend a little bit of time talking about regression, since that's what's coming up this week, and then maybe a little bit of time on mediation and moderation. And actually, I do want to spend a minute or two talking about some model development stuff that really deals with regression and mediators and moderators. Okay, so again, a lion's share of the time may be spent with this data set, but that's, just have to just let me know how things are going. Ask questions if you want. Feel free to. In the view that I have, I don't have access to, I don't see the chat pane, I don't think. I don't think I have access to that chat pane. So anyways, if you may have to get my attention if you have a question beyond that. So what I have here though is the fossil data. So this was collected a couple of years ago, not that long ago, and it was for a project with a couple students. That we did together, and what we were doing was basically measuring. Um, we did an analysis where we measured people's perception of Fossil brand and then other brands of watches, and we were really distinguishing between hybrid smartwatches and full smartwatches, and some things like that. And we wanted to capture some personality and some personal traits of consumers, and kind of how they viewed making purchases in this kind of area, and what types of brands they were ultimately attracted to. So the study, the data set itself is pretty large. This is only part of it. And it really, just for illustration purposes, it was, I kind of created it this way for this assignment. The sample size, you'll notice, is pretty large. We had well over like 1,400, yeah, 1473. So it was a good response size. And the demographic that was hit here were young adults. So it was a convenient sample that we used, primarily from colleges and universities. But it made sense because of the product category and the idea that this product category would resonate with younger adults who might be buyers of this brand, or this type of smartwatch type of a thing. So that's kind of a little bit of a background. I think you had access to the survey, so you probably saw the questions directly. And that's actually really important, because you'll notice that like the questions that dealt with these first few variables were asked one way, more like a Likert-like scale, and then the style questions were more like semantic differential scales. So where we had two anchors, two different opposite sort of emotional or personality traits anchored on one end or the other. And you could go in and kind of look and see what those were all about. Then we had familiarity questions, 3 for smartwatches and then 3 for hybrid watches. And there's actually a distinction between the two. One of the research objectives was to pick up and see if the degree to which people knew the difference between the two, and either were familiar with or were not familiar with these types of products. So as you're looking at this, I mean, we've got these questions and we've got a bunch of data. So first things you look at just naturally would be sample size. I don't know how many, let's see, it's probably 8, let's see, there's 14, 6, probably 28 questions, something like that. So we have, like I said, a lot of respondents. So plenty of sample for the number of questions that we're asking. It certainly would meet any type of confidence interval calculation that you'd want to make, or the five times the number of items rule for basic analysis, certainly cover that. In fact, there's an opportunity here if you wanted to just do a subset and just randomly select, like a couple hundred, like 200 or 300 or so, and run your analysis on a subsample. You could certainly do that. So you could do a holdout sample, run some analysis for preliminary work, and then do a confirmational analysis to confirm your findings with the rest of the data if you wanted to do something like that. That's not always necessary. Some people will ask you to do holdout samples, but the point is we have a large enough sample that we could certainly do that. You certainly should probably double check on things like missing data and outliers. I don't know if I didn't read in any of I don't think I recall seeing in your homework assignments any mention of double checking that. So you may have done that and not let me know, or I might just be forgetting it. But looking for outliers, looking for missing data is something that would be appropriate with any data set, especially if it's new to you. One of the things we can look at, and just so you can see, you know, like if we looked by by variable, again, these are all of these are scale. There are no nominal or ordinal variables here. They're all scale variables. So we could we could just look at the descriptive statistics for each of these variables, and we could look at missing under the missing percent missing, and so we could see if there are any variables that are missed by a good margin, or ones that were not answered. Again, my computer's super slow, so so we have questions here. There are some questions here. If we just look again at the case processing summary, we have some questions here that were not answered by everybody, and I'm not sure this is exactly what I wanted, to be quite frank. Hold on just a second. Let me just double check something here. Let's exclude this pairwise, and let's just see if that makes a difference. Oops. There we go. All right, that's better. That's what we wanted to do. So, so there was a question last week on pairwise and listwise deletion, and I didn't quite get it 100% correct. So if you delete by listwise, what it'll do is, if a respondent misses any one item, it'll completely take that respondent out. Whereas pairwise will continue to include that respondent for the other items that they answered, but not for the item that they didn't answer. So in this first, when I did this explore, in this first explore that was done, this was a listwise deletion, and so what it did was it deleted out respondents if they missed any missed any item, any of the items, it would take them out. So you see the N is 1108 instead of the 1478, because 365 respondents missed at least one thing, and so they were taken out in this listwise deletion. So when you do a listwise deletion, it takes the entire respondent out for all of the analysis, and a pairwise deletion takes it out only for a variable by variable analysis. So you lose more data if you do a listwise deletion as opposed to a pairwise deletion. That's what it is. And again, you can kind of play around with that and kind of see what the impact would be. But that's kind of what's going on there. That's why there's 365, because 365 respondents missed at least one item, so they were taken out in that one run of the data. Dropping down, doing, oops, sorry, I got too much going on here. There we go. Doing a pairwise processing or a pairwise thing, all this does is it looks by each variable. So for the variables Tech 1 through Style 14, all of the respondents answered those questions except for 2. Now, interestingly, when we get to the familiarity questions, we had a bunch of missing data. There's a bunch of people who did not answer the familiarity questions. 307 did not answer the first three, 111 didn't answer the last three. Now, I can't really remember what the reason why this was, but as a researcher, that would raise kind of a red flag that there's so much missed on these questions. And to the point where you wonder if it's like non-random, like if it's something systemic. Like, so when I see something like this, a lot of times my experience is that um, maybe the survey went out and maybe there was something wrong with the like skip logic or the logical thing, where maybe some of the people saw these questions but some of the people didn't, and so they didn't even have access to them. Or maybe two versions of the survey went out and one version was slightly different than the other, and it either allowed them to take these questions and maybe didn't allow others to take it. That's what I've seen before. I've done a survey before that was paper and pencil, and it was like front and back. So like there were questions on one side and then there were questions on the other. And I've done a survey, and that same survey, I've done it where people answered the front, but then they didn't realize there were questions on the back. And so for those people, there was a bunch of missing data because they didn't see the back of the survey. And so that was very disappointing. That was a sad day because, it was something like an artifact of the actual survey that caused that missing data. And so I would like really question or wonder if that's something that's going on here. Now, again, I didn't ask you specifically to do that like as a part of the homework assignment, so don't sweat it. I'm just saying that this is stuff that you want to look for and think about, kind of with the data set, no matter what. As you kind of approach a new data set, this is part of the getting to know the data, thing. So one of the things we didn't do last week, but we can do this week, we've got this issue here. So just quickly, how do I deal with, and how do I determine if these missing data are important or not, or whether it's something I should be concerned about? The cutoff is 10% or so for missing data by variable. So, the fact that 99% of the respondents completed the rest of the survey means to me that I don't have problems with individual respondents. I have problems with these questions. That's what sort of is the suggestion here. And so what is it about these questions, or what is it about the respondents who didn't answer these questions that is different? And are they different? Are these like 307 different from the rest? That's kind of the question. And if they are, then we may want to exclude them from evaluation. We might want to take them out of the sample. Again, we have a very large sample size, so we could afford to lose this many, and the analysis would be fine. So the 20% here is an issue. The 7.5% probably is not so much of an issue. It's under the 10% rule, so wouldn't so much worry about that. But my guess is that if they missed these last three, they also missed these first three, and so they're probably the same people. All kind of bunched up here. The 111 are probably embedded in this 307, be my guess. So here's what you do. We're going to create a couple variables to specifically look at these 307 that have not answered those questions. And what we'll do is we'll compare these folks to the others and see if they have behaved differently on the other variables. It's basically what you do to see if the missing data is impacting your overall analysis to some extent. Okay, so what we're going to do is we want to, let me walk through this the right way. What we're going to do is we're going to go into to transform compute variable. Uh-oh. Where did it go? Where's my compute variable? Where's my, sorry, I'm looking for my dialog box and I don't know where it is. Oh no. Oh, there it is. It's on the other screen. Okay. Sorry, folks. Is that what yeah. I'm gonna do missing values and missing. So I double click on this and let's just name this missing data for now. So with this function, and I don't believe we did this fully last week, so we'll just include this. I specifically want to look at the folks who missed these questions here. So I'm going to put in and separate by comma the folks who missed these 6 questions, because they're the ones that I'm really kind of concerned about. All right, so what will happen here is a new variable will be created and it'll count how many times each person missed these, and it'll either be like a number 0 through 6, basically. So hit OK. We'll take a look at our data set just to see what it looks like. And we've got this here. So now we've got this new variable. So this respondent here, this number 20, missed 3 of those 6, and we can see them all. They're all right here. So we can see these 3 here that they missed. Go along. We have another one who missed 3, 3, 6, 3, and so forth. So it looks like to me that, again, something probably happened in the survey where people missed those questions and just didn't answer them, or I don't know, it's kind of weird. Some of them answered them and some of them didn't. But that's kind of where it is. So now I've got this variable though, where people either are a 0, they didn't miss any of those 3, or they missed something other than that. So now what I can do is I can do some comparisons, and I can compare like these groups of missers versus non-missers. So like I can go with a independent t-tests would, yeah, it would be okay. And I can do missing data. No, I gotta create one more variable. Sorry, I gotta create a nominal. So this is really not grouped data, even though it says it's ordinal. It's really not. I've got to create one more variable to actually create 3 groups. So a real nominal data. And what I'll do is I'll recode into a different variable. So this is actually, so walking through some of this may actually be informative and help a little bit, just some techniques that you can do in SPSS. So I'm going to call this missing dummy. It's not really a dummy, but it's kind of like a dummy. And the, so I'm missing them. So I'm going to create a new variable. And if the value is equal to 0, I'm going to make that a 1. Okay, so in other words, anything in this missing data column, if it's a 0, it's now going to be a 1. So that's somebody who didn't miss anything, right? If let's see, for simplicity's sake, if somebody is a 3, then I'm going to call them a 2. And then if somebody is a 6, if somebody missed 6 items, then I'm going to call them a 3. So I'm basically creating 3 groups, right? Just 3 groups, 1, 2, 3. And this is really kind of the way you could do it through a range, which might even be better. Like but this will suffice for what we're doing, I think. Okay, so I'm actually going to create a new variable, which is a true dummy variable. There we go. And now we can compare groups better. So analyze, compare, we're going to compare groups. We're going to use this new dummy variable. So let's compare, for instance, people who basically didn't miss any to the group of people who missed missed three of the variables, three things, because that seems like a group that we're concerned with. Okay, and what I'll do is I'm just going to grab some of these variables up here and just look and see if our missers behaved any differently. I'll just grab these tech and fashion ones. I just want to see, again, just let's see if there's any difference in behavior between those who missed and those who didn't. So I'll click, let's see, options. We're good. We're good with that stuff. We're not going to worry about that too much. Okay, so again, these are the people who missed versus the people who didn't. So the people who did not miss any of these questions are those last three. The ones who completed the survey for the most part, like their mean score on these variables are like 3.57, 3.24, and so on and so forth. The people who did miss a lot of data, like the people who contributed missing data to the data set, their mean score on the exact same variables are 3.9, 3.57, 3.7, and so on and so forth. So here's what we're looking at specifically, and we can kind of come down here to actually look at these, like the significance test. When you look at the people who completed the whole survey and you compare them to the people who missed those three familiarity questions or three familiarity questions, when you look at those two sub samples, we're asking ourselves, are they different from each other? Is there something different about those who missed versus those who didn't? And on these variables, we've got 8 variables here. There's a significant difference in the average scores between those who completed the full survey and those who missed. So, I mean, we're looking at pretty significant differences. These finished the survey in this particular case. Now, this is pretty data or not keep this data, and from these respondents or not. Again, this wasn't something that I was asking you to do, but it is a carryover from week 1 in terms of kind of getting to know the data and some things that you can do to help assess your data. So when you collect data for other projects, if you're collecting it yourself, I would definitely run this type of analysis and just make sure that missing data is not kind of a big issue. Okay, so that's kind of there. Again, there are videos that describe this process as well. So you can watch those and kind of think about, assessing that. The next question is what you do with these respondents. So let's say you have this data and you have these respondents and with this missing data right there. And let's say you still want to use that respondent and you don't want to discard them. So the follow-up question is what you do, if anything, with those empty spaces. Do you put something in there called imputation? Do you add something? Do you create something in there as a marker or a holding spot that's appropriate? And so again, we go under transform, replace missing values, and you would for a specific variable, like we would go in here and we would, maybe for this specific variable where we know 20% of the respondents missed this, then we could put something in there that we think would be reasonable. So sometimes people replace with mean. That's an option that's offered a lot of times here, actually, in this analysis. So what'll happen is the software will just calculate the mean for this variable, and anytime there's a missing space there, it'll just put in there the mean. So as a result, that inputting that shouldn't have a dramatic impact on the data set overall. You may do this, you may not. It's just one technique. There are, again, the text talks about a cold deck, hot deck approach, and also a regression-based approach, where the software will estimate a value that's most appropriate based on the characteristics of this respondent and their other the other data that they provide. So what they'll do, what you can do is you can find somebody else in the data set who answered similarly to this respondent, and then basically look and see what that person put in for the missing value and replace with that value. So in other words, this person is missing data. I'm going to find somebody who's very similar statistically to this person, and I'm just going to use that other as a supplement or as a proxy. So that's something that you can do as well. And so just under method, you've got a couple different options that will kind of outline and do those things. Okay, so identifying missing data, how severe is it? What's the source of it? Is it impacting the rest of my analyses? And then what should I do with it? It's basically the questions that you're asking when you're dealing with missing data. Another thing that you want to do, or you probably looked at doing, was maybe look for outliers. Certainly, when we talked about that. So when we take an account of the Mahalanobis d-squared statistic, that's kind of one of the ways to do this, and it's probably a good way to think about. And so when we do that, we're going to run a regression only to get this statistic, not to actually get any estimates or values. It's just to grab this statistic. So what I might do is I might just take a variable and then select some of these other variables as examples. And I'm going to use, I don't know, I'll use these 8, I guess. And you don't have to be too selective. You can just kind of pick some things, and then click the Mahalanobis d-squared. You can also click Cook's as well, which you may do in regression and other things. They both measure distance. Mahalanobis d-squared is a better measure though. So that's kind of, you know, what you probably want to do. Again, that's under save. Whenever you do save, it's going to create a new variable, and that's the variable that we want to look at. And remember, so what we're doing here is we want to evaluate data at a minimum that's 2.5 times the number of independent variables away. If it's larger than that, if the Mahalanobis d-squared statistic is larger than that, then we have a potential outlier. And so that's where we would be concerned. So we're going to run OK, and we'll go back over here, and we'll look at our data, and we'll see we've got this new variable. So we had eight independent variables. So 2.5 times 8 is 20. So anything above 20 at a minimum may be considered a bad variable. That's fairly restrictive with a large data set, but that's okay. We'll maybe sort. Well, yep. Where's my sort? Sort cases by Mahalanobis distance. We'll go descending. And this is just a visual thing. You can do. So we've got several here. We've got a bunch here that are above 20. So anything above 20, would be potential outliers. In other words, individuals who are not behaving the way they're behaving more outside the norm than inside the norm. With large data sets, though, you can actually expand it from 2.5 upwards to 3 or 4 as a multiplier. So we could actually go a bit bigger. If we said, say 3 times our independent variable number, would be 24. So it's okay with a larger sample size to actually bump that up in terms of your criteria, your cutoff criteria for outliers using this method. So that might be something that you'd consider. So we got some outliers potentially. We have some missing data to think about, and again, this is kind of a review of the methods. You want to, again, just kind of get familiar with running these types of analyses. We have lots of data sets available to you just to practice and examples in the text. That leads us sort of to the actual assignment. So factor analysis, again, I'm not going to mess with taking anything out because I don't think you guys really took anything out. So I want to kind of try to duplicate what you went through. But again, factor analysis is this idea where we want to group and regroup variables that hang together, that go together, that seem to measure the same underlying concept. So the nutshell here is that there are some things we measure that are hard to measure, and we are looking for multiple items that will reflect a more complex like construct or internal construct or something here. So we ask 3 questions for familiarity for smartwatches. Do we need to ask 3 questions? Well, familiarity itself as a construct can be defined a number of different ways. And so maybe one question isn't enough to explain all the variance in that construct. But if we ask 3 questions, then we have a better ability to cover the variance or explain all the variance that construct may have. You notice like the tech questions and the fashion questions, they relate to kind of how focused somebody is kind of from a personality perspective on technology versus fashion. And so again, keep in mind the product category, we're asking people about jewelry because a watch is a type of jewelry. Jewelry is like a fashionable thing and it makes a statement. And, you don't pick a watch just because it's there. You want it to go with your style, go with your outfits, go with your personality. You want it to reflect you. So that's kind of like it's a fashion statement in choosing a watch. But now because the idea that it's a hybrid or like there's a technology involved with it, you could very much see a tech person being focused on the technical aspects of why it works and how it works and will it function the way it's supposed to function, is it reliable, and all this other stuff. So the product category, it's not like a strict fashion wear, but it's also not a strict tech wear or anything like that either. It's like a blend. So that's why we thought it was important to measure these 2 dimensions. At the same time, these dimensions are hard to capture with only 1 question. So we felt like multiple questions would be appropriate. And so that's what we did. We designed these questions that way. The style questions are very different and they're really challenging. There's no doubt about that, because these deal more with like emotional personality type things. And yeah, some of them you would expect may correlate with fashion or technology, but maybe or maybe not. And some of these may go together, some of them may not go together. You can look at the survey and you can kind of see which ones you think should sort of naturally fall with each other and which ones shouldn't. There's one in there that's reverse coded. There's one in there that asks, I think, whether a person's more like an Apple or an Android, which is completely unlike the other 13. I mean, it just was weird. It doesn't really fit in there particularly well. And so, you know, when you're dealing with a composite, or when you're dealing with a collection of items like this, you got to be a little careful, because the reality is none of them may go together. I mean, they just may all be separate dimensional type things. Or you may have a few that go together, but they're just really, really challenging. So when you're actually designing your survey and you're doing personality groupings like this, um, this is a real tough type of thing to measure. So and I know this is a challenging set of data, these questions in terms of, you know, trying to put this together. But, you know, we wanted to see what would work and how that would all pan out. So as I look at this, we start our factor analysis. First question we want to do is we want to start to look at the actual items to confirm that the items are acceptable variables and they have acceptable traits for analysis themselves. So we'll pop down here, dimension reduction. Okay, so remember, we're taking like a bunch of variables. I think there were, what, 28, something like that. And our goal is to try to reduce them down into like these composite variables. And, you know, inevitably we got like the 4 tech variables, and we're going to maybe, if they hold together, we're going to combine them into one composite variable. So we're going to take those 4 and make 1 out of it. So we're like taking our data and we're actually reducing it. And that's why it's a data reduction type of a method here. And so we're going to go into factor, and we need to, so initially here we're just looking to see, we're looking at the variables because we want to identify the degree to which they conform to this type of analysis, that they meet the requirements that we would hope they would meet in terms of doing this. So we're going to go into descriptives. We want to do a correlation matrix, we want to do an anti-image matrix, and then the KMO Bartlett's test to start this out. To be honest, we're not particularly interested in the rest of this because we don't know if these variables are even sufficient yet for analysis. So we could check a whole bunch of things here, we could do that, but we're not ready. So I'm going to do okay. I'm going to do a correlation matrix, and then you're going to see the items here that we have. All right, so the correlation matrix can be helpful. It can also be awfully confusing to try to follow along. And generally, a lot of these methods are based on inter-item correlations, like a lot of multivariate methods. Again, they are kind of based on the interrelatedness of variables. So a lot of them use, as a result, some form of a correlation matrix then to do the analysis, to handle the back end of the analysis. So like if I'm looking at this, I look at these tech variables, and I look at like the size of the correlations in the tech variables, and I see like a 7, 729, 673, 7061. This 519 may be a little lower, but what I'm going to do is, like, I'm presupposing that these tech variables are going to fall together, and if they do, in fact, hold together, I would expect them to have pretty high correlations with each other. And they're okay, they're not bad. Tech 4 and Tech 1 isn't great, but it's not the end of the world. If I slid over and looked at the fashion items, so fashion with fashion, I've got 721, 665, 6780, yeah, 771 and 79. Those are all, you know, really good and high. So again, kind of, I'm presupposing that the fashion items are going to fall together with each other. And, you know, just anecdotally, I'm looking at the correlations and they're high. So it seems to make sense that they're going to fall together in the actual factor analysis. At the same time, if I looked at like these technology variables against the fashion variables, what I would expect is to see fairly low correlations, because I don't really, I mean, my hope is that the tech variables and the fashion variables don't correlate with each other and don't fall on the same factors. Like I wouldn't expect them to, I wouldn't predict them to anyways. And so I would hope that these would be fairly low correlations. And, in respect to everything else, they are fairly low. They're 1.5, 1.5, 1.2, 2.0 looks like the highest one out of the mix. Compared to all these high 7s and 8s, those are fairly low. So that's kind of the idea. Now, once you get into the style, it's a whole mishmash of all kinds of craziness. And then also some of these here with the familiarity scales, you'd have to go way over to the side here to see what they were doing. These familiarity scales like 8.8, 9.2, 9.0, those are good together, and so on. So there's some here. It looks like the familiarities, these are cross familiarities between smartwatches and hybrids. 5.2, 5.9, those are still pretty high, and these are scales that I thought would separate. So I don't know if they will. So the correlation matrix actually gives you a good amount of information just as a cursory. The Kmo measure, again, this will talk about, like, is there enough inter-item correlation for factors to form? Doesn't really know or suggest or predict what those will be. All it's saying is that there are items that correlate with each other in a sufficient amount that they should hold together. So again, above 0.7 is fantastic. Bartlett's test is good. It's actually pretty, I found it to be more or less pretty rare for these not to be supportive. So you can use a lot of data sets, even if they're not great data sets, and you'll still find these to be acceptable. But that's fine. It's worth doing. And then finally, the anti-image correlation matrix. So not the covariance matrix, but the correlation matrix is what we're looking at below here. And we're looking at the diagonals, which I think just about everybody looked at. And these diagonals should all be above, what, 0.7 or something like that. Can't remember if it's 0.5 or 0.7, but these are all super good. These are all high. There shouldn't be any real issues with these. Yeah, they're fine. So okay, initially then we're good. No problem. We're good to go. It looks like the data, at least at this point, is sufficient. Here, hold on just a sec. Okay, we had a bunch of rain and now the sun's out. Go figure. So let's do some analysis. Let's do some factor analysis then. So we're going to go back here. We got our variables. We're not ready to dismiss any yet. Again, if you look at the survey, you can sort of like what'll happen is when factor analysis can be really sensitive. So if you have items where the scale changes, then a lot of times those items won't fall together. So like the style questions are asked in a different way than the other questions. So I would be extremely shocked if any of the style questions loaded with the others, for the simple fact that they use a different scale. I know that's weird, but the way you ask questions and the way they're responded to, it absolutely impacts your data in terms of what emerges from it. So if you change up question style or question types, it'll almost always cause problems with a factor analysis. The other thing that will cause big problems is if you do any reverse coding in your questions. So if any of your questions are anchored in the opposite direction, then it will mess up that item will almost never fall into a factor the way you think it should. So, so if you decide to use a reverse coded question in your survey, I would do it only as a manipulation check or as a check to make sure that the respondent is sort of paying attention. And then if they fail that test, then I'd consider dropping them from analysis. But the actual item that you're using that's reverse coded, it's probably going to be problematic when it comes to this analysis. So I think one of the style questions is reverse coded. And when you do it, you'll notice that there's like a negative factor loading. So, I mean, basically what you do is you reverse it so that it's not negative anymore, because you should never have a negative factor loading. It should never be there. A negative should never be in the factor loading. And so you should reverse that and then rerun it and see if it still holds or not. And I've never had really any, I've never really been able to hold a reverse coded question in a factor analysis. So just FYI. All right. So anyways, we did this factor analysis. So we did this KMO stuff. We did the anti-image stuff. We really don't need that anymore. You could keep running it if you wanted to. All right. So when the factor analysis happens, basically the data is sent in, it creates a solution, and then it does some magic. And there's an initial solution, and then there's what's called a rotated solution. So we usually don't use an initial solution for our our coefficients or our loading factors, but inevitably it's checked there, and it doesn't hurt anybody to keep it there. Extraction. All right, so we're definitely going to run a principal components analysis. So the CPA or PCA analysis is really where you want to stay and not really worry about some of this other stuff. It's okay not to worry about that. You can certainly check out a scree plot. Again, the unrotated or initial factor solution is a bit, it's not always necessary, and not really a whole lot I'd really worry about in this course. Scree plot's helpful, and we'll look at that when we get it. Now, the number of factors extracted is really something that you can play with as you go. The initial rule is this idea of an eigenvalue and the number of factors that produce enough or account for enough variance to matter, I guess is a good way to think about it. And so what will happen is the eigenvalue will be calculated, and if this is checked, then it will produce a number of factors that have eigenvalues greater than 1. Now, you may not follow that rule. Like, you may be absolutely certain that you know how many factors you think should be there, so you can force it to do a certain number of factors and give you the number of factors you want. It's okay to do that. The eigenvalue greater than 1 rule is kind of standard, but it's not a, you don't always have to. I mean, you can input this, you can change that if you want. So in other words, if you know or you really think that there should be more factors, and we may try that. I know some of you did that. You forced a certain number of factors, and that's not wrong. It's a tool that you have that you should take advantage of. But we're going to start with eigenvalue greater than 1, rotation. All right, so this is a good question here.
Mike?
Oh, yeah.
I just had, if we could go back, even a question about the extraction. If you go, yeah, the maximum number of iterations for convergence. I would get that error. I had got that error as well. What does that mean? I tried to.
Yeah, so what this is going to do is it's going to run the data over and over and over and over again until it has a solution, kind of like bootstrapping. And so if you did you change this?
I did change it to 26. I first changed it to a higher number, then I changed it to 26, and it was, I mean, because and it would say it cannot go beyond. It would not show me anything then.
Really? Like, did you put
Yeah,
like
and that's what I was
100?
like.
Did you put like
I tried to
100?
look.
Or?
I couldn't figure out what exactly it does. Then I came back to 25, but
Um,
and that was after, because I was trying, because I mean this, there was an issue with this tile factoring, so I was trying to get I mean, when I had tried to increase the number of factors, like
yeah.
and then so it would give me this error.
Yeah, so like you increased this to a
It was,
bigger number.
I'd increased it to, first I'd increased it to 9, and then
Yeah.
it gave me that error, and then I,
I'm kind of surprised it did. Now you can put this to a pretty high number if you want,
oh
like
really? Okay. I thought it
200 or
was gonna throw me.
300, or I mean,
Oh,
yeah.
okay.
We can play around with it and see if we can get the same error,
Okay.
and just see what works. Yeah,
Okay.
yeah. And we'll actually come back to iterations in a couple other techniques where we'll modify it a little bit. And
Okay.
let's see if we can make it fail and at
Okay.
some point, and we'll just try a few different things and see what works.
Okay. Okay.
Okay.
Thank you.
Yeah. Okay. So rotation. So, like, not to get too deep into it, because some of it matters, some of it really doesn't. But basically, the idea is that what you're doing is you're laying the data on like a grid, and you're putting all the data on there, but you have multiple variables. So it's not like a 2 by 2; it's a n by n type of a chart. And what the data wants to do, it wants to force. So each factor is kind of like an angle off of the grid. And what it'll do, it'll make an initial solution, and then it'll rotate around until it gets the optimal solution, where the least amount of distance is accounted for in each factor based on like a Cartesian plane. I know I'm not explaining that particularly well, but the bottom line is, if you use a Varimax rotation, what it does is it suggests that factors do not correlate with each other, whereas a Promax solution suggests that they do. It's a little bit more flexible. Um, Now, if you run both analyses, you're probably not going to come up with much difference between the actual factors that you identify, and you may not even have much difference in the factor loadings that emerge. So it's more like a philosophical thing. Do you think that the factors share variance with each other or not? So like if I did just the tech and just the fashion variables, and I had two factors and I did a Varimax, what I'd be saying is that those two variables are don't have any correlation with each other whatsoever. And, just kind of like philosophically, that's a bit of a stretch. I mean, you'd think that they'd share some variance, at least maybe not a lot, but at least some. So I think the textbook uses Varimax a lot, which is fine. I happen to use Promax a lot, which is fine. But there's not a strong argument between using one or the other. Okay, so you're not going to gain or lose a whole heck of a lot if you choose one method or another. But I do want you to know that they're equally out there in terms of availability and what people will use and what people won't use. I actually I did a paper. I just did a paper. I had it reviewed 2 or 3 weeks ago, and one of the reviewers was really mad that I used Promax and not Varimax. And so I had to rerun the analysis, and I think the reviewer was wrong, but I don't know, they thought they were right. So anyways, you'll get some people who are kind of like fixated on running one or the other. But I don't know. I don't think it's worth getting too worked up over, to be quite frank. So anyways, you might have used Varimax or Promax, one or the other. You should specify, and you should kind of think about why you're using one or the other. The text talks a little bit about orthogonal and oblique rotations, and I do a little PowerPoint on it as well. I have a video on it. So that's good just to kind of think about, but that's where it relates. All right, scores. Again, with the scores, we're not going to worry about that quite at this moment. So when you do the scores, you're going to have an option to save variables. And this is actually a good way or an easy way if you want to do composite scores that are like proportional value composite scores. That this is a good way to just, it'll calculate it for you. So that's an option there. Other things. So, okay, exclude cases listwise, exclude cases pairwise. So here's the question: how many data points do you want to lose? This is where this comes up. If we do listwise, we're going to lose at least over 300 respondents, because that's over 300 respondents, missed at least one variable. If we do pairwise, then it's just going to calculate everything variable by variable. Even though somebody might have missed some questions, it'll still run the analysis on the other variables. And so some variables will be run with like 1,470 respondents. Some variables will be run with 1,100 respondents. It just, each variable will be run with a different number of respondents if we do that. Another option is to replace with mean. And again, so this means we'll have no missing data. The missing data that is currently in there will be just imputed with the mean of whatever that variable is. Okay, so it's kind of up to you. A lot of times, we could run it a number of different ways and actually see if there's much difference here. I'm going to throw in replace with mean for now. You might have done something different, but that's a decision that you want to think about. The other area here, I know some of you picked up on this, sorting by size helps readability. The other thing is suppressing small coefficients does as well. And so like this happens when you get the factor loadings. And, when you're deciding on retaining a variable, or you're deciding on whether there's a cross-loaded variable, you want to look at the size of the actual coefficient there, the factor loading that's there. So generally speaking, I look for factor loadings to retain that are above 0.6 or 0.7-ish. That is not a hard, fast rule. Some people go down to 0.5. It just kind of depends on what your tolerance is for factor loadings. Cross loadings, I tend to be very concerned if things are like 0.35 or 0.4, something like that. So if I'm looking for variables that are, say, anything above a 0.3 maybe, then anything below 0.3, I really don't need to see. I just don't need it cluttering up the screen. So I know some of you, again, did this. So, and if you watched the video, I know you saw it about this type of thing. So again, it's just a way to clean up what's going on. All right, so specifying all of this the first time takes a little bit of effort, but we're going to run it, see what happens. All right, so communalities. This table here doesn't really give you a huge amount of information. In fact, I don't really ever look at it much, except that if you see things that are particularly low, this 495, these fives is 383, the 244. What this suggests is that this particular variable doesn't explain much variance, as in any way to the rest of the data set. So, it may be that these guys eventually fall out of the analysis. I wouldn't be surprised. The higher they are, the better. The lower they are, not so great. So again, doesn't tell you a huge amount until you start looking at the other stuff, but it might give you a preview of what's going on. All right, we said eigenvalues greater than 1. I know a number of you suggested 8 would be sufficient because that's awfully close to 1. Because we set that rule, though, the analysis will only be done on the first 7 because the first 7 have eigenvalues greater than 1. And you can see that the first 2 factors explain a significant, I mean, a lot of the variance. But this is kind of true. This is often the way it is. And that doesn't suggest that the later factors are less important or less valid. It just means that this is the way the data is structured. That these ones at the beginning probably hold together better. They're probably going to have a stronger or higher reliability and all like that. The scree plot is going to be a plot of this chart here. Now, keep in mind, for each variable, you can have a factor. So we could have actually asked for up to 28 factors if we wanted to. Now, that would be kind of silly, but we could if we want to. So that's why there's 28 here, and the scree plot will actually have 28 potential factors that we could have, one for each variable. And we sort of look at this, and it's kind of a curiosity. There's a little bit of a break here. So after the fifth variable, and then we kind of get down here, you know, you could say, okay, well, that one's pretty close, but we're really right on the line here. Maybe this one's really close. Where does the break really happen visually? You know, even though we're using the greater than one rule, you know, you could make an argument that it breaks somewhere in here, and maybe we use the first five or something along those lines. So I would say this is probably more inconclusive than conclusive, but at the same time, this is exploratory, so we're going to try a bunch of different things. This will not be our final solution here. All right, so since I used a Promax solution, we're going to run with a pattern matrix. And we're going to look at some anomalies. We're going to look and see what kind of shakes out and problems. Now, you'll notice there's a lot of blank space because everything below 0.3 was suppressed, only meaning that it's just not shown. So wherever there's a blank here, there's a value. It's just not being shown to us, okay? So there is stuff here, but for clarity, this is the way this looks. We ordered it by the highest values first, so that's why it's sort of in order the way it is. And you know, now it's kind of like, all right, we've got this stuff going on here. We've got to kind of think about what should go, what shouldn't go, and what's supported by the data. So first of all, this style 3 is an issue. It's a negative number. Style 2 is a negative number. Something's going on with that. So just FYI, we shouldn't see negative factor loadings. And this is like, it's not a beta. It's not something that could be positive or negative. We just shouldn't see these negative things. It squirrels up the data. It just isn't pretty, and it's not the way it should be. I have not looked at the actual survey in a while, so we could actually go in here and factor analysis, look at the actual survey, I suppose. And we're looking at 2 and 3. All right. Oh, okay. So so please use the adjectives below to best describe your personal style. So number 2 here, style 2, Apple or Android. Those really aren't like personalities. I mean, those are like really weird. I mean, you know, in terms of like the others, they're not like the others. If you said which is not like the other, you'd point to that question and say that one's not like the others. So that's the deal with that. Fashionable functional. The issue with this is it appears to be like reversed. Like maybe functional should be on the left side and fashionable should maybe be on the right. But then again, I don't know. We have artsy and analytical, and we have, yeah, maybe, yeah, I don't know if that's question is anchored correctly. I guess maybe is what it is. it seems like we have the further extremes on the right: excited, spontaneous, extrovert, aggressive. But then again, we also have this emotional and logical. So I don't know, there may be something going on with that. I can definitely see number 2 here being an issue, but we shouldn't have these negative things going on, the factor loadings. So that's something that will, whoops, that we would probably question right there. The bottom line though is it doesn't load on anything else. So that's like the other underlying thing. It doesn't load anywhere. And style 4 cross loads and doesn't load strongly on anything. So style 4 is a little bit of an anomaly. Style 2, like we mentioned, it's that Android, that weird question. So that's an issue. These guys here are kind of low, although they're not terrible. They're just a little on the low side. We've got a cross-loading, potential cross-loading here for number 6, and this is so low at 5.0, it's probably going to be an issue. Potential cross-loading for style 1, although that's pretty low and that's pretty strong. And then potential cross-loading for style 10. Okay, so it looks like there's like 5 or 6 variables here that are questionable. The other thing that I'm noticing here is that the familiarity scales break out the way I thought they would. Fashion and tech break out the way I thought they would. Those look like they're pretty clean, with the exception of these style things. So we can go at it like that. So I wanted to kind of like lay this out on you, because this is something that you can think of as a researcher. You're exploring, right? So nobody needs to see all the mess that you go through. Like, your client's never going to want to know all the steps that you take and all the hidden stuff here. What they're going to see is the result. So another approach that you could take is that you could actually split the data up a little, split the variables up, and do some of the analysis on some variables, get a solution, and then do analysis on the other variables. That's something that you could do too. So we did all 28 variables at once here. We could, if we wanted to, just sort of step back a little bit and do what we know. Like, I feel very confident that these style variables are kind of messy. But at the same time, I think that these other variables are kind of good. I mean, these other factors I think are going to be nice. Just, I think they are. And so I could actually just do the analysis with these first. And so, like, I just did it, and these are all really popping up real nice. This Tech 4 is still a little low, but it was earlier too. We got 4 factors. Look at the break between 4 and 5 just in eigenvalue. That's huge. So we got this big break here, and then it flattens out. So you're looking for where it flattens out, where there's this. So this is actually the scree. Like, if you look at a mountain and there's rubble at the bottom of the mountain, that rubble is called scree. That's what it is. It's a scree plot. So this is like the rubble at the bottom of a mountain we're looking at. And then we're looking at this, and look at that. So if I don't even mess with those style variables, look at how pretty that pattern matrix looks like. Look at these. These are all fantastic. Those are like, that's like beautiful. That's what every researcher wants to see. So if these hold together like this, maybe what I could do is I could maybe now look at this, just the style variables, and maybe I could run the style variables together. Eventually you have to run them all together anyways, but sometimes if you're really struggling, sometimes you can do it backwards and do an iterative process this way. And that's, again, the client's not going to see all the back and forth that you do. They're just going to see the end result. so this style 5 is nutty. These are all kind of a bit low, right, compared to what we had before. We have 5 factors that are emerging from this, potentially 6 if we look at that 9, 2, 5. So anytime you have like a slope that's sort of sloping, that's a bit problematic. What you want to see is a clear break, like a slope, a straight line down and then a flat line. That would be better to see. In this case, we're not really, it's kind of like a loop rather than a slope, rather than a break. If we look at the pattern matrix, again, we've got 12, 13, and 14. I don't know what those, we'd have to look at the survey and see if it makes sense that those go together. Then we've got 7 and 9, and then really kind of this muddle here. We've got 4 and 6. We've got 1, 8, 10, and style 11 is just kind of all over the place. All right, so what I often do here when I start looking at this, I'll look at probably the most egregious variables first and start taking them out. I usually don't try to take out more than 1 or 2 at a time, because every time you take out a variable, the solution changes. So let's say 11 is just, it's not significant, it's not really strongly loaded on anything, and it's, if anything, it's being cross-loaded. So let's at least take 11 out. So we'll run this again. We'll take 11 out and see what happens. Run it again. Again, we're got, kind of the same sort of mess. Oh, it's just even uglier. Yikes. Yikes. What do we do here? Oh, the style 6. Could take that out. I don't know. Any suggestions? Anybody want to take? We could take 4 out. 4 out. We could take 6 out.
Right. You're looking at component matrix.
Oh, sorry.
All right.
Thanks. That's good. Was I looking at it before? I don't know if I was or not. Okay, style 3. That's not going to work. Style 3 will not work. I can tell you that right now. Analyze style 3. Oh, look at that. We're getting a little bit more of a hard break in there. That's a little better. Style 5 is just, that's not going to work. But these are starting to look like they're at least holding together better. That's still super low. So maybe we'll just, that might go up, just if we deal with some of these other things first. So again, this is a process of messiness. It's just trial and error, and it's ugly. I mean, there's just no other way. And sometimes you never get a really good solution. But if we looked at taking, and I'm just playing around at this point, style 5, take style 5 out of there because it was cross-loaded on a bunch of stuff. All right, and style 2 maybe. Finally, we'll take style 2 out of here, and then we'll just kind of see what happens. Factor, style 2. All right, so we've got four factors. They seem to really break just right here a bit. Again, this is not pretty, and I can't remember what your final solutions were on this, on these style items, but they're ugly. That there's no way. Now, I'll say this, like for an academic journal or something like this type of result would never work. We'd have to collect data again. We'd have to use different variables. We wouldn't use this probably in really a lot of analysis. But if this is the data, this is the data. So sometimes you have to deal with the data that you have. And so, it doesn't mean that the project's a failure. It doesn't mean that it's the end of the world. It just means that the data is not perfect. And that's okay. That's not the end of it just is what it is. But that's kind of one approach to go for. So let's see, I can't remember what you guys had, but we have dimensions, we had these styles, we had these other variables. Eventually, like I said, you have to have everything run together. You can't do things without, independently for very long. So we're going to run this analysis. As we run it, we've got some of these other things that pop in here. How you decide to deal with these style items are probably going to be kind of your decision. As a general rule in factor analysis, you want to strive for at least 3 variables for each factor. So if you see something here where you have 2 variables, and let's say I wanted to drop 12, you're really moving away from a scale when you do that. You really want at least 3 variables per factor to move forward. Yeah, the style 4 is, you got to take that out probably, and so forth. Okay. All right. So any questions then so far? Again, this is kind of a messy, iterative, back and forth thing. You could certainly run the data from the textbook, and I don't know whether it's the HATCO or the HBAT data. They've got a couple different data sets. But the example in the textbook, one of the things that the textbook data will probably be is a little cleaner, and it'll be probably a little less messy. So, it's not as realistic, because this is like real data. It's not as realistic as this real data would be. But if you want to work through some other examples, the data is there for you to really hone your skills on this if you'd like. So the next step then is to look at reliability. So reliability is important. There's 2 things to know. One is you want to make sure that your data reflects reality to the best of your ability. So whatever the measure is, we want to make sure that the measure is capturing like what's happening in real life. So we call that validity. So when there's like structural and internal validity, it means that the items go together and they reflect reality somehow to some extent. Now it's not going to be perfect, we all know that, but we want our measures to reflect reality to the best that they can. The other thing that we want to do is we want to make sure that our measures consistently measure the same thing. So like over time, over uses, over different samples, and even within the sample, we're measuring the same thing across respondents. So when we measure the same thing across respondents and across samples, then the measures are said to be reliable, that they perform and they act the same way in measuring reality, consistently. So reliability and validity are 2 different things, but they're closely related. You can't be valid if it's not reliable. And so we measure reliability a couple of different ways. And generally speaking, what we want to do is how consistently, we want to take a measure of how consistently the variables hold together. And so it's pretty simple to do. The standard bearer is Cronbach's alpha. But the other things that get reported may include composite reliabilities, CR, and average variance extracted, AVEs. So there's in SPSS, again, we look at this basically, with scale and then reliability. I think everybody did this fairly accurately, and we want to take. And so this is one distinction. We don't take all the variables together. We only take the variables that are within a factor. Okay, so we have the tech factor, and we had those items that made up that factor. And what we're going to do is we're going to do reliability. We're going to ask for alpha. There's actually a bunches of ways to do this, but the standard again is called Cronbach's alpha. And so that's what people will look for. So we'll do okay. Reliability, 0.872. So again, kind of the basis for this is 0.7. That's sort of the benchmark that is generally viewed as acceptable. You know, the higher the better. If it gets into the high nines, then people start to question the scale a little bit. You know, the items are too closely worded if it's too high. The paper that you guys read for the discussion question paper, if you'll recall, do you guys remember what they used for a cutoff?
0.5.
Yeah, 0.5. Now, again, this is an academic paper, not probably in the best journal in the world, but you know, researchers will use different cutoffs, but generally speaking, 0.7 is the better thing. So this brings up an issue, though. I know that when you do the factor analysis, you usually end up with a couple factors that include those style variables, and those style factors don't have particularly high reliabilities, right? So in fact, they're not above 0.7, but I think they're above 0.5. So there again, as a researcher, you decide whether you're going to keep those or not. If my client wants to know, like, how personality issues impact, like, their view towards smartwatches, I'm probably not going to discard those variables. I'm probably not going to discard those factors just because my reliability isn't 0.7 or higher. I mean, you see this article here, again, they used 0.5 or higher, and they had I guess, a legitimate, you know, kind of reason to do it, or they had their own process for doing it. So so I wouldn't be too quick to throw data out just because it doesn't meet a strict rule, especially when you're being pragmatic and you're working with a client. Now, in the back of your mind, are you concerned? Yeah. In the back of your mind, do you use this as a liability, like something wrong with your data, and you might want to, you know, kind of be concerned about it? Yeah, sure. But that's just something to be kind of cognizant of and aware of. Okay, so that's that. I think some of you did, I think all of you, or most of you did, the composite reliability and the Cronbachs and the AVEs for these. So those calculations are not easily done in SPSS. They're not directly and easily done in SPSS. So if you didn't do that, just make sure that you're aware of the process. In our Blackboard, there's a file here, the AVE and CR spreadsheet. And again, in the videos, I explain how to do this. So if you watch the videos, then you probably did it, or you were aware of it anyways. And basically all you're doing is you're plugging in the loadings, the factor loadings into this. And the way this works is I've created a little area here. If you have a 3-item scale, you put your factor loadings in right there. If you have a 4-item scale, you put your factor loadings in again right there, and so on. So if you can do bigger scales if you want, but we have 3 or 4-item scales. I think the tech one, these were 4-item scales. So we just put our factor loadings in there, and then this calculates, so it walks through the various steps on calculating what AVE and what CR is. And so again, you want something north of 0.5 for AVE and 0.7 for composite reliabilities. But look, if your alpha is solid, these are going to be fine as well. They kind of are redundant in a little ways. And again, no client's going to ask you for 3 forms of reliability, I don't think. A professor might, but I doubt a client would. So, or if you're peer reviewed, they might, for sure. So any questions so far? Good. All right. So then the last part of this then would deal with the composite scores. Okay, so again, what we want to do is reduce our data. So if we have 4 variables that reflect technology, then I could, and we know from factor analysis that those 4 variables go together, they support one another, they hang with each other, they reflect an underlying concept that we think is important. So if they all kind of go together, then what we're doing is we're creating one variable that reflects them all. Now, what you can do is, again, kind of pop over here. We've got this data, and we've got these variables. We could take like the average of these variables and just do a simple mean average for these. We could do that, would not be that big a deal. Just go like to transform, and in this transform we could do, I'm just going to call this tech AVE for tech average, and you could do the average. I can't remember what it is. It's one of the functions over here, or you could just create your variable just like you would anything else, where you just add these up and divide by the number of variables that we have. So if we're going to add these, we'll tech 1, 2, 3, and 4. And then we take that sum and divide it by 4. It'll give us the mean, right? It's the mean of that particular variable for each respondent. And so we'll just hit OK and just look at our data again. So take these 4 variables, and now we've created a new one over here, and it's this tech average. You can do that. So that's okay. We can do that. Another way we can do this, though, is when we run our factor analysis, we can ask it to create a composite variable that will basically take the factor loadings and weigh each response based on the factor loadings that are there. And it's a little bit more precise, but it won't be that much different from this average, to be honest. So again, do factor analysis. Just for simplicity, let's just do this. Let's just do these variables just so we don't, it's all going. We know this is going to come out to be 4 nice clean factors. Now we're going to do a score though. And sorry, I have to get that over there. And we'll do a regression. And so basically what's going to happen is the factor loading a version of the factor loading will be used and applied to each of the respondents' responses. And then a global score for each of the 4 factors will emerge. So just do that as a score. We'll run it. We're not really worried about all this other stuff. What we're worried about are the new variables that were created. We have 4 new variables that are created, factor 1, 2, 3, and 4. The tech factor is going to be the second one. So the second factor was our tech factor. So in the new variables that were created, the second factor is what we're going to use, and it equates to this average that we just had. Now, you're going to say, whoa, look at that. That's weird. Those are weird numbers. Those are positives and negatives, and nothing's really very big. This was on a 5-point scale, so how on earth, at least with this tech average, we know I think it was on a 5-point scale, so we know it's going to be between 1 and 5. you know, on the average. This one is nuts. And so basically what's happened is it just produced a standardized result. So this is a standardized result as opposed to a non-standardized result here. If we did the correlation between this mean and this score here, it should be pretty close. They should be pretty close. Something that would, in this category here, in this column here, that would be close to 0 should be fairly close to the average of these averages, I would guess. I don't know. I'm curious. We should try this. I may fall flat on my face, but let's see if this isn't right. Do that one and then that. These two, this should be fairly close to 1. Yeah, look at that, 0.99999. Okay, so being real sophisticated and taking a real sophisticated weighted approach to create a composite variable versus just simply taking the mean, you end up with almost the same result, to be honest, you know, in terms of form of composite variables. But that's what we do. So that last step then is this formation of a composite variable. Being able to do it a couple different ways is helpful. And now I can say, well, look, you know, like I can start doing some analysis. Like I can look at, I can compare people, you know, people's fashion scale to their technology scale. I can look to see like their level of like how much they are aware of the products to these things too. So like somebody who's like more aware of a product is maybe I could say someone who's more aware of a product is more techie. I don't know if that's true or not, but maybe I could say that. And we could kind of see, you know, through some type of analysis. Or if I had other variables here, like if I had people who owned fossil watches, I could see where they were on these scales, like on average. Or if somebody had an Android or Apple or some other type of device or a Fitbit, or, you know, whatever. I could look at, you know, all the demographic splits. If I thought there was a difference between men and women on how they viewed like technology versus fashion, I could test that. So now I can use these variables, these 4 variables, in a lot of different ways. And they accurately, and I'm confident that they reflect the reality of the dimensions that they're supposed to reflect. Okay, so that's kind of it. I know that's a lot. Factor analysis, each of these methods, there's quite a bit of analysis. But once you do them, again, if you feel overwhelmed or if you feel like that's a lot or if you feel like you'd have trouble duplicating this, that's natural, that's normal. This may be new to a lot of you. So it's like just practice makes perfect on it. If you want to get down to it and practice a bit, there's this opportunity to do that. Any questions? Guys doing okay so far?
Yeah, I had a question. So
Yeah.
if, for example, so if you don't, the style variables do not become a factor, you can still use that. You can still use that for different and other analysis, right? It's not like we're
You could.
removing it completely.
Yeah, you certainly could. So just because the variable doesn't load on or gather onto factors, so you could treat it like a univariate analysis where you have just a single variable that, and every once in a while we'll do this, where a single item measures a single concept. And that is perfectly fine to do. It's not wrong to do that, actually.
Okay.
So right, and like I said, those personality ones, they are hard to measure. Ask Dr. Hare, because he does a lot of consumer behavior stuff, which I don't, but he does. but measuring people's personalities and kind of their interests that way and whatever, you find a lot of single item, we call them single item indicators, because it's a single item and it's indicating one thing. You could still use the data for other analyses, or you could use any one of these factors, because now these are just numbers, and you could use them with any of the style ones you wanted to do.
Okay.
Yep.
Okay. Thank you.
Great question. Good question. Okay, so just to finish up kind of the factor analysis.
Dr. Fight?
Oh, yeah. I'm sorry.
So I just needed clarification on one of the things you showed us in one of your videos. At the end of a video, you showed like a weighted score. I wanted to know if it's the same thing as the step that you just did now.
It is.
Oh, okay. This
Yeah,
is like
well, yeah, there are a couple different ways to do it. Oops, that's the wrong one. There's a couple different ways to do it. This was a way that we used for the software to do it itself.
yeah.
If we go into the actual matrix here, and we could actually use these numbers that are in here,
Yeah.
and we could use these as, we could like standardize these and use these as weights separately. So there's like a couple different ways to do this.
Okay.
That very last one, kind of like if you take a mean, then like if I took a mean of these variables, then basically what I'm saying is each one of them is worth 25%. They're each equally, the same weight.
Yeah.
But you look at the size of these loadings, and you know that they're not all technically equal.
Mhm.
You know what I'm saying? So like if you wanted to be more precise, you could use a system where you use these as weights to, and then apply them to whatever the respondent indicated for each one of these variables, and then do some type of an average that way, like a weighted average. Honestly, and some researchers will be pressed hard to do that, and that's fine. And what we let SPSS do just now was perfectly good. There's nothing wrong with that. It's probably more precise than just taking a simple mean or average. But at the end of the day, there's not a whole heck of a lot of difference between the two.
Okay. All right, great.
That's a great question. All right, cool. Let's look at, so just again, I won't spend, because we've been going at it for a while on factor analysis, but we did have a discussion, and in this discussion there was a article. So one of the things I like to do, or just mention about the articles here, is that this is like somebody did real data, a real analysis. They collected stuff, and as a researcher, it's helpful to just read other other projects and other work that's been done, because like you get ideas yourself on how maybe a process should work, or how what they did well or what they didn't do well, or you can kind of get a feel for, you can critique their work, but then you can also pick up on pieces that they did that, like you would like to implement yourself. So this particular article deals with using market intelligence or information from the marketplace and how they make decisions. So specifically, they're talking here about market research and marketing intelligence systems, the importance of information that supports decision making, and so forth. So that's kind of what the focus of this article, and it's not really that important to really know or understand all the theory behind it. What I'm more interested in this application is kind of the data collection and the actual process of the research. Okay, so there'll always be a little section here where it says kind of what the purpose is of the research. And again, you should know why you're doing your research. Like you should have like some statement as to what you want to accomplish, your research objective and stuff like that. With that said, though, they talk about their data collection process and sort of how they went about identifying their sample. They went ahead as far as talking about how they stored their data and kind of the process they used to put their data together. They used a survey and all. What the big focus on the paper for us today is really dealing with is their method as we cruise on down to their methodology. We have their research questions. That's good to know. But really the methodology here is kind of what we're looking at. Again, following the purpose of their research to determine the relationship between marketing intelligence and strategic marketing. They did a survey. Okay, fantastic. They looked at businesses with 100 more employees and a certain level of revenue. They had a sampling frame of about 700 respondents. So these would be companies that met those criteria. And then they went out, they launched a survey. They did this over the phone. So this is a telephone interview type of a thing. Each one took between 10 and 15 minutes. They did quota sampling, which meant that they wanted a specific percentage or proportion of respondents from different criteria that they had. In total, they had 176 usable respondents or sample. Okay, so their sample size is 167. So that, should give you some feedback. They had a sample frame of 700. So you could look at kind of like their response rate, and you could think about whether that's good or not, or manageable. You can think about whether 167 is a good number. All scales used a 5-point Likert-like measurement. So you know what Likert-like scales are, 5-point scales. We've already talked a little bit about how short scales tends to limit variability in the data, but it's scaled data nonetheless. Okay, they talk here about the different sections of the actual instrument. So they had perceived importance of 13 different types of information. They had a market intelligence scale, 13 items. They had 8 and 5. Okay, so they had different categories, they have different items, and they have some different usage stuff. Okay, and I think there's a chart in here. Pretty sure there's a, there's a table 2, I think, and some of the other tables actually list the items. So you can see what the items were that they had. Hey, they used SPSS software. Yay. They used a Verimax rotation. Okay, no problem. We know what that is. They use the eigenvalue. Eigenvalues less than 1 were screened out. Hey, look at this. I think they used our textbook as a reference. Okay, we could do that too. They looked at the correlation matrix. Okay, we reviewed that. They used KMO. They used the Bartlett's test. All things that we do. So they're doing the same stuff that we would do. They opened up the textbook to whatever chapter it is, and they followed the guide. They looked at commonalities, and so they had ones that were greater than 0.8. Or they have some criteria here where they removed some that were low. Again, I don't use the commonalities table. I don't put a lot behind that to speak of. If a variable is gonna not work, I'm gonna see that later on. So I'd rather see it later on and make a decision about it. So they used factor loadings of 0.5 or higher. So again, I like to use like 7, 6, 7 and up, but 0.5 is fine. That's good. Minimum factor loadings of 0.32 were considered cross loadings. Now this is really peculiar because 0.32 is not like a number you would naturally just wake up and say, I'm going to use 0.32 as a cutoff. It's like arbitrary. And what tells me is like the researchers did their analysis and they just looked at their analysis and then they decided what their cutoff would be, which is kind of backwards. You're supposed to decide your cutoff and then apply it to your data. And this is like a real big red flag if you're like looking at data and somebody says their cutoff was 0.32. Because again, nobody walks into a project and decides a priori that 0.32 is going to be a cutoff. It just ain't going to happen. So anyways, with that said, they had a cross-loading level. And again, I usually use 0.4. 0.4 is my benchmark that I usually kind of use, but that's okay. Everybody does a little different. Cronbach's alpha were used, and again, they used a benchmark of 0.5 here. I would suggest 0.7, but that, you know, is what it is. They used that, and that's what they decided to go with. But this is all stuff that we're doing, that we're talking about. They looked at correlations, as we've already mentioned. So they talk a little bit more about some correlations here. You know, and that's fine to do. They talk about this a little after the fact, but that's okay. All right. And then so that's the data. That's what they have. And now they talk about their results. So they actually, I guess, had 166 responses. Made sense. And then they talk about kind of how some of this goes. And in some of the tables, so we'll just drop down to some of the tables, I think, for, well, okay. They report a little bit more about their actual results here. The suitability of the data to use. Again, they reiterate their alpha loadings and stuff. So here's the table though. We have the factor loadings here. So knowing these factor loadings, we could compute their composite reliability in the AVE if we want. We don't, you know, because we have that spreadsheet. So we could put in the spreadsheet what these factor loadings are. Again, I'll point out you typically want more than 2 items per factor. So the fact that they have 2 here doesn't really produce a very strong scale. And technically, you should use the correlation. You really don't run an alpha on 2-item scales. You run a correlation. So just FYI. Again, this is kind of low. Again, this is borderline, and this is, you know, pretty low too. So you know, and just look at the factor loadings and look at the reliability. You got a 0.885, and then you drop down to a 0.554 and a 0.452. So with factor loadings that are so spread out, it's kind of like no surprise that the alphas aren't particularly strong. Yeah, like these are indicative. If you see factor loadings that are fairly close to each other in number, then you're probably going to have a fairly strong alpha, and especially if they're high. Like if you have a 4-item scale and all the items are in the 9s and 8s, you're going to have a great alpha. This is just a struggle here to try to pull together, you know, really strong factors. Now, again, that doesn't mean you stop. That doesn't mean you don't do it. That doesn't mean you don't report to the client. You know, maybe you revise the scale and relaunch it. But again, you know, you probably report what you got and make some analyses there moving forward. Yeah, some other, so those were those. They've got some more factors and items here, I believe. Correlation matrix. Okay, so this is something that we do. again, assuming that you pull together a composite variable, you certainly can look at factor correlations. So the correlations, not between items, but between factors. So they have like 4 factors here, and you look at the degree to which these factors are correlated. And those can range. They can be high. It's okay for those to be correlated there. Just means that 2 factors are close to each other in similarity. And that's kind of another thing. I know I mentioned earlier the idea of oblique versus orthogonal rotations. Like if you had a truly orthogonal relationship between, say, factor 1 and 2, this would be 0. There'd be 0 correlation, or this would be 0. There'd be 0 correlation between factor 1 and factor 2. But the idea here that these 2 factors correlate suggests that you should let them be an oblique rotation or use a Promax rotation instead of a Varimax. Now they used a Varimax rotation, but their factors correlate. So, that might call into question something. That's another thing. I had a review just recently, and the reviewer looked at my data, and they suggested I do that was one of their arguments. They said they were wrong. They said that there's too much correlation between the factors, so I should run a Varimax rotation. But the fact that there's correlation suggests I should do a Promax. Anyways, the little idiosyncrasies here pop up. I think it was table 6, maybe. We got another table coming on here. Okay, a couple more factors. I can't remember whether they did all of this at once. They should have. But it looks like they ran 2 separate factor analyses, but they technically you're supposed to run them all together. Again, we've got some interesting factor loadings going on here, but we have a pretty high alpha. One thing to note is oftentimes with the more items you have, you sometimes get a little bit of a bump on your alpha. So, having a larger scale is sometimes good. Because it helps balance things out. But moreover, a lot of these numbers are pretty close to each other. So maybe that's helping the alpha a little bit there as well. And then again, we've got this factor 2 here, ICT support, an 8, 8, 6, and then a 6, 5. Those are all pretty decent in terms of where they are there. Okay, so again, honestly, I haven't jumped in and haven't had a time to really add a lot of comments to the discussion board yet, and kind of in there. I know the discussion's over, and we have a new one this week on regression analysis. But again, I think that reading other reports and other kind of researchers' work isn't a bad idea when it comes to kind of refining your own skills. And honestly, by looking at this, you can kind of begin to think about, well, why did they do this? Why did they do that? Is this appropriate? Would I have done it differently? And so on and so forth. Okay, any questions then so far? We good? You guys are troopers, I have to tell you. You're doing great. I hope these sessions are beneficial. I know that, technically an online course means that everything is online, and it's hard to have, class time, I guess, if you will. But this is typically what I would do if we were doing it face-to-face or hybrid. So hopefully this works at least to some extent. So moving to this week, the topic for this week then is regression. And regression, multivariate regression is, something you're familiar with. I have no doubt that you've done regressions and you've kind of seen and kind of done this before. And some of it will be really review. Some of it will be a little bit more detailed than what you've done in the past. that's okay. The other thing that we sort of introduce here is the idea of doing some modeling. And regrettably, we don't do a lot of model work in this class. I guess technically all of these techniques include creating a model. When you do those factor loadings and we do a score, a composite score, you're creating a model. But what I'm talking about is when you think about taking like constructs and relating them together, specifically relating them together. So like, for instance, if I look at maybe the effects advertising has on sales, then I'm looking at this idea of advertising level or advertising support, and I'm looking at growth in sales, and these are two different variables. They're two different ideas or concepts, but I think that they're related. So I create a model that says advertising support is positively related to sales by some degree. And so I go out and I collect data and I measure that and I identify how much impact advertising support has on sales. And it's usually some multiplier, some factor. So if for every dollar I put into advertising, I can expect a certain dollar amount out in new sales. And so when I create a model, what I'm doing is I'm sort of relating variables together using some theory and using some past experience. And then I'm going out and I'm collecting that data and I'm evaluating it, and I'm getting a parameter and a coefficient, and then I'm going to use it like for some forecasting. So that's one thing that we don't really do particularly a lot in this class. We'll do some in 530, but when we do regressions, it's probably the clearest and most compelling time to talk about model development, because when we do it, we're dealing with here, let me pull up what I need to pull up. When we do this, we're dealing with a dependent variable, and then independent variables. Oh, whoops, sorry. Hold on, I'm trying to pull up a file. Apologize for the delay. Let me see if I can find this. Where do I need to look? Sorry guys, I thought I had what I needed. Pull this up here. So we just want to spend a little bit of time talking about this idea of some modeling. And as we look at this, I'll just say there's like these, oops, kind of as you can see here, these three ideas. I want to, as a researcher and as a manager, as a marketing manager, I often see something that is happening, like in this case, change in sales, or change in a consumer behavior, or change in my competitors, or change in the economy, or something going on like that. Or I anticipate some change happening, and that's some type of an observed, I call it here behavior. It's really not so much a behavior, but something that's observed, a phenomenon in the marketplace that's happening. And so that's the root of all research projects, is in something like this, something that you observe and you're questioning why this is happening. So when a manager comes to you with a problem, when you're being asked to do some type of research, it's because something has been observed, some behavior has changed, some metric has changed, something's going on that's unexplained. And so that's kind of the first thing when we do this, that in model development, we want to think about that. So oftentimes this might be the dependent variable, right? And regression, we look and see what's being changed or what it is. Next thing we often do is we ask, what is influencing the change? What is causing the change? What is interacting with the change? What is happening in concert with the change? You know, what other things are going on that we can associate with the observed behavior that's happening? So these are often our independent variables, or other things that are happening. And then we want to know what specifically the influence is. So are these independent variables contributing to the change? Are they limiting the change? Are they exasperating it? Is it positive? Is it strong? A heavy influence, a light influence, and so on and so forth. So if you kind of think about like observed behaviors as our dependent variables, as these influencing variables or influencers as our independent variables, if I said that correctly, and then what the influence is, think about that as like beta. You know, is it positive? Is it negative? Is it big? Is it small? Then that really helps describe kind of what's going on. And so when you're model developing, though, you're kind of like got this blank slate and you're thinking about what variables should go where and how and in what order, and you're theorizing, you're kind of predicting, and you're trying to guess. Okay, so that's kind of where we're going when we start talking about regression, and moreover start talking about models. If you you can look at your textbook and specifically look further on where it starts getting into simultaneous equations. So I can't remember, I guess it's towards the end, it always is. Chapter 10 or chapter 9 is a good place to look. Chapter 9 does some pretty cool modeling work where you have like multiple levels of models. You know, you might think of it as like nested regressions, several nested regressions happening all at once, or hierarchical regression where you have multiple regressions happening all at once. But that's a good chapter because it lays out pictures, and pictures kind of with arrows where one variable sort of impacts another variable, or maybe 5 or 6 variables impact another one. And again, it kind of goes back to this idea of a regression model where we have multiple independent variables and they're all impacting maybe a dependent variable, right? So model building is kind of fun, and but it's also, you know, kind of where we're getting into next, and kind of the next level of analysis. So there's like descriptive analysis, and then there's causal analysis. And when we start model building, we're doing causal analysis. So some key concepts just to kind of root ourselves. I mentioned this thing lots and lots of time, a theoretical construct. So when we start talking about theoretical constructs, we're talking about basically concepts that may or may not be directly observable or measurable. But these key constructs are things that we need to measure, and they form our variables. So in the factor analysis we just did, fashion was a construct. It was an idea of a concept that we wanted to try to measure. Now, whether someone's fashionable or not is really not observable. I mean, I could look at somebody and I don't know whether they're fashionable or not. I guess I could see what they have on or whatnot. But honestly, fashionability is sort of an internal trait. It's an internal thing that you have. And so we have to ask several questions in order to capture that concept and measure that concept fully. So in our research, we had 4 questions that held together that I feel confident that they measure the concept of fashion sense or fashionability. Fashion then is a theoretical concept, and we're operationalizing it by asking those 4 questions. Okay, so that's kind of where it is. Now, whatever we want to know is rooted in some type of a theoretical construct. It can be any type, any variable that you want to think of that you might use or be familiar with is rooted in some type of a theoretical concept that we're measuring. The actual question we ask, well, that's just the measurement type, the measurement that we're using that measures the concept. But the theoretical construct is what we kind of are dealing with. Theoretical models, it's just, you know, when we take these concepts and we put them together and we try to show a relationship among them, that's a model. One thing is causing another. One thing is happening when another thing is happening. One thing influences another. You know, anytime we talk about that, those things are these constructs, and the interaction between them is the model that we're predicting. Okay, so again, when we start doing regression, this is what we're doing. We're creating a model because we're saying that these independent variables impact the dependent variable somehow. We're predicting that. We're saying that that's going to happen. We're theorizing that that model holds. Okay. A couple other things that you're familiar with already. Measures. So the actual questions or device we're using to capture a quantitative number or measure a degree of a construct. Sometimes, we're using a 5-point scale. Sometimes we're using a 100-point scale. Sometimes we're using a Likert-like kind of device. Sometimes we're doing semantic differential weight, you know, with anchors and all like that. Lots and lots of different ways to create measures that measure some underlying construct. Again, we spend a lot of time on measurement development. We just spent factor analysis. Anytime you create a survey, you think about the questions you're asking, you're thinking about the measures. You're devising ways to capture a value associated with a construct. And then finally, of course, we look at our sample, and we could add other things here, but I just put the things that I really think are most important with this type of research. When you're dealing with model building, you know, your model should hold. It should be what we call generalizable. So in other words, the model that is correct is the model that is measured accurately for multiple groups of respondents. So that's like a big test. Like, say I have a model of behavior and it works for young people, but it doesn't work for older people. Well, that model of behavior has a problem. It's not generalizable. Or maybe it works for a Western developed economy, but it doesn't work for a you know, an economy that is not developed as much. Again, the model doesn't work because it's not qualified, or it doesn't incorporate maybe enough variables to take into account these distinctions. It's not generalizable. It doesn't have enough variables in it to fully capture reality. So the samples then become really important. I mentioned earlier the sample with the fossil watch data. We specifically chose young adults because we felt that that sample was appropriate for the product category. It was very specifically chosen. We didn't feel like other samples would be appropriate because maybe they wouldn't be familiar with the product category to the extent that they could describe you know, like likely users of it or whatever. So anyways, that's kind of where we came down on that. So this idea of regression then is a model building idea. What I don't want you to do is just randomly throw variables into a model haphazardly without really thinking. Once you get to a regression, you're not so much exploring. Factor analysis was exploring. We did a lot of exploring in factor analysis, and it was really messy, and it was really kind of ugly. When you get into regression, you're actually making hypotheses, and you're making predictions, and you're using some type of theory or concept to drive why you're using the variables that you're using. So it's a little bit of a different step, you know, in terms of analysis or in terms of approach when you do a regression, because we're moving into a model mode as opposed to exploratory mode. Now, other techniques we use this term, they won't be so model focused. In fact, this is probably the closest that we're going to come to actual model building in this particular course. So the other techniques may very well revert back to exploratory analysis, but this one here you just want to be aware of is kind of a different animal. All right, so so the other part of this that I want to just mention, and I don't know how much detail we're going to go in on this, the homework assignment has, the last question of the homework assignment deals with mediation and moderation. So I want to describe what these are. And you may have had this in other courses, so I'm not sure. I don't know if you've seen or heard the idea of mediation or moderation in the past. I will tell you that in the in Blackboard, under coursework, we go into regression analysis. So this week's material, there's there's obviously all the stuff that you need to see with videos and stuff. There's also a folder here though on mediation and moderation. And there are some examples, of walking through some of the steps here that you would do for both. So you may want to look at those. You may want to watch some videos. Mediation and moderation are very common. They're not always done well or done correctly, but they're something that you'll probably see kind of in other applications. So basically the idea here is that, and I'm just going to step through this one little picture at a time. Mediation happens when you're creating a model and you have an intervening variable that happens in between the independent variable and the dependent variable. So again, we're talking about regression here. So focused on regression, that's one of the ways that we identify this. It is the way we identify it actually. We've got a dependent variable, so that'd be like your y variable, I guess. And we have an independent variable, that'd be an x variable. And we're saying that the independent variable causes or influences or affects the dependent variable. That's like no mediations happening here. This is a significant relation. The beta is going to be something significant. It's going to be high. So what we're saying when we have mediation is that there's some other variable that is acting in between the two. So in other words, we're saying that there's not a direct thing happening, that there's some step that's happening between the independent variable and the dependent variable, and the variance of that initial relationship here is actually being captured through this mediating variable. So there's steps or successive steps that are happening. So you might think about like the consumer's decision-making process. Like in consumer behavior, you learn how consumers go through a series of steps before they buy a product. So you can't just go from need identification to purchase, right? You have to go from need identification to evaluating options and, one thing after another. I can't remember what they all are. Again, Dr. Hare's a pro there. But the point is that you can't go from step 1 to step 5 without going through the other steps, typically. And so you have intervening steps involved or intervening activities or actions. So if that's the case, then you would have some type of mediation before you get to this dependent variable. And so this is an idea where this is called full mediation, where there's a full step here. So what we might do is we might measure this, and we might measure this relationship here as step 1, and then use step 1 to create step 2. So this could be something like a 2-staged regression that you're doing, where you do one step and then you use the first step to do the second step, basically. So there's two-stage regressions. Again, hierarchical and nested regressions. There's are all somewhat similar types of things where you do a step first and then you do a second step after within the model. The more common thing, actually, and something that you'll see, is this idea with partial mediation, where you still have this direct relationship going on, but you add to it this other relationship going on. So this mediated variable is actually partially influencing the dependent variable in conjunction with the original variable there. So if I was gonna like write this out in a formula, we'd have the y, which is the dependent variable, then we'd have a constant, and then we'd have the beta. Oops, I have to draw this out a little bit. We'd have the beta for the IV, and we'll put this like this. And that would be this no mediation type thing. That would be this direct relationship. Full mediation would be a little something different, because there'd be this embedded in here would be the mediating variable. But this partial mediation, the way it looks, is we'd have a second beta thrown in here. And in fact, what we'll do is, let's see if I can, oh, no, that's not what I wanted to do. Let's see if I can do beta 1, and then this will be beta 2. And this is going to be the IV, but then we're going to multiply it by whatever that mediating variable is. So this second term then incorporates this variable in here. No, actually what we do is we would have, I'm sorry, we would have it wouldn't quite be like this. I apologize. It would be a different thing. I'm going to back up because I'm just confusing myself, and I know I'm confusing you. I apologize for that. Partial mediation happens from time to time. It's actually something that we can model and test. In your 550 class, when you do your project, you may ask Dr. Ram about this, or he may ask you specifically. If not, ask me if you have any questions. And this week, you're going to see this in the homework assignment. So anyways, sorry, I shouldn't have even tried that little illustration. There's a problem when I go off script sometimes. All right, the second thing that you want to look at, or that you'll see this week, is something called moderation. And this is actually very, very common, and we do it through ANOVAs, and we also do it in regressions as well. So in a moderation, so moderation and mediation are two different things, but we often talk to them about them together. In moderation, we have our original relationship between the independent variable and dependent variable. But then what we do is we introduce another variable that influences this relationship. So down below here, we have kind of the idea where if we have a dependent variable and independent variable, and we have a relationship going on here, that's what it is. But when you factor in this moderating variable, the relationship changes. So like, it wouldn't be enough to just describe the model as direct. You would be missing something. And so you want to add this moderating variable to the mix to reflect it. So again, going back to this idea that if I have a model that works for like young consumers, but it doesn't work for older consumers, then age is probably a moderating variable, because it has some influence on the model itself. Like, it's influencing the relationship between the variables somehow, and it should be accounted for. So in other words, to be more generalizable, and for the model to be more acceptable, like in more circumstances, then if I added age as a moderating variable, it would probably capture what it needs to capture. And I could, you know, and the model would work for multiple samples. Okay, so again, tonight, I just wanted to, you know, we've covered a lot with factor analysis, and there was a lot to do with that. But what I really wanted to do is just kind of like lay out this concept of model building, and that there are certain steps to take. Mediation is a nuance of, you know, kind of a model that involves that involves regressions. To test for mediation, for instance, you use a series of regressions, and you measure these different the betas on each of these different arrows, and you determine whether the influence of this mediator, you know, if that changes the original the original relationship or not. Moderation, again, slightly different, not the same as mediation, but it's the introduction of another variable to a model that changes the relationship between the IV and the DV. Okay, so so that's moderation and mediation. Again, regarding the work this week, there are a number of different examples that you can work through. Again, the data from the text uses, I believe it's HBAT. The new homework assignment uses a new data set. So we introduce a new data set to you. Now the homework assignment this week, I want to just offer a little bit of just a caution or just an update. When you look at it, you want to kind of evaluate it like you would any data set for just the overall data, whether it's suitable for analysis. You'll need to do a factor, part of the homework assignment has you do a factor analysis on some of the variables, not all the variables, but some of them. It has you do some regression, and then it has you use a composite score from the factor analysis to do some more regressions, okay? So again, the homework assignment this week, it incorporates sort of multiple steps that you've been working towards. And it just gives you more practice doing this stuff. And again, the goal here is that you get comfortable using these methods. You know, it all takes practice, obviously, but the more you do them, right, the easier it gets. So so that's kind of what that's all about. All right, so you know, we've been going at it for quite a while. I've been, you know, kind of nonstop. You guys have any questions? I trust that the pace of the course is okay. I know there's a lot of material each week. I get that. It's, you know, try to scale it so that we do a method a week. So we're going to do regression this week with mediators and moderators. And then there's and then the week after this, I guess next week, is it next week? Is the week where we do the midterm. So I will have I'll probably have, I feel fairly certain I'll have some material this week up regarding the midterm. So like Monday next week, what we'll do is we'll review regression. We'll review the regression assignment. I usually have a little bit of a kind of a pause because we're not going to do new material next week. We're going to we'll review regression, but we're not going to do a new method or anything next week. What you'll have is the exam to work on, which will be due, again, Sunday evening. I think that's the 5th, it should be, just like your other homework assignments would be. Okay, so you'll have all week to work on the midterm, take-home midterm. And I should probably have that up and available at some point this week, but to be quite frank, I wouldn't worry about it this week. I would do this week's work this week and then let next week take care of itself. But anyways, I'll try to get that up so you can be previewing it if nothing else. And certainly at our Monday next week, we'll review regression, and we'll certainly talk about the midterm and answer any questions and things like that. Okay, that sound good? You guys doing okay? Yeah. Multivariate analysis, it makes the world turn. It really does. It's again, some of this stuff is new. Some of these techniques you'll use a lot. Some of them you won't use a lot. But the more you get familiar with them, you better it all works. Any questions before we wrap up? You guys are troopers. All right. Hey, I wanted to say that I thought this week's homework assignment, the factor analysis homework assignment, was pretty good. It wasn't bad. Just all around in terms of your work. I think I commented, just very generally, at one point in the responses, that the more detail you do, the better. Like, because there's a lot of decisions to make, and what I'm looking for mostly in your homeworks is your process, like your process of analysis, and the steps that you take in getting from point A to point B. I mean, you're going to get from point A because that's where you start, and you're going to get to somewhere, point B. And like for factor analysis, you know what, if you had a 6-factor solution or an 8-factor solution or a 4-factor solution, a lot of it's going to be kind of how you got there more than what you got at the end. And so if you provide more feedback, more description, if you continue to describe your process, then that helps me understand if you kind of are comfortable with doing this stuff, or areas that I can emphasize more where I see problems just as a group, or things that I can point out. Okay, so again, I thought the homework assignments were pretty decent, really. I feel as far as the group goes, I'm pretty confident in everybody. I don't see any big red flags or anything like that. So just keep on trucking along and try to have fun with it. Be an explorer. You're a detective, it's the data. So see what you can find. And seriously, I know. And also, you may be able to integrate some of this stuff into your internships and your work. And you may be doing some of this stuff already there. I don't know. But if that happens too, then that's pretty good as well. Okay. All right. So anyways, if you guys don't have any other questions, I'm going to let you go. Anything else? Okay. We'll see you then. Let me know if you have any questions. Shoot me an email or whatnot.
Thank you.
Thank
Bye.
you.
Well, thank you. Thanks for your time.
Thank you.
All righty.